Okay, Assalamualaikum. Today we will present about chapter 4 matrices 4.4 system of linear equation with three variables. This is our group members with one Muhammad Alif bin Muhammad bin Wan Kamaruzaman. Say hi Alif. Okay. Ahmad Fitri bin Ahmad Kamal.
I
Say hi. And I is Muhammad Arif Aiman bin Muhammad Rizal. Okay. Today learning outcomes is 4.4 system of linear equation with three variables. So it asks us to write a system of linear equation in the form of ax equal to b and find the unit solution to ax equal to b using inverse matrix. Okay. This is a short and quick note. So using inverse matrix to solve ax equal to b. So we need to use this equation to involve inverse matrix. If A is an if A is a n by n square matrix that has an inverse A, so X is a variable matrix and B is known as a matrix, both with n rows, then the solution of matrix equation Ax equal to B is given by A uh, given by X equal to A inverse times with B. This is proof. So AS equal to B, which is B is a 3 by 3 square matrix. So we put A inverse both sides. So A inverse times with A will get the identity. So it comes it be identity times X equal to A inverse times B and X equal to A inverse times B. So this is the equation. The equation asks us the following table show the price are per type of 0.5 kg cakes sold at the shops P, Q and R together with the total expenditure if a customer buys a number of each type of cake from the listed shop. So cake types we have a banana, chocolate and vanilla. So shop P sell a cake, banana cake 5, chocolate cake 8, vanilla 5 and the total expenditure is 36 ringgit. Q 4 for banana, chocolate 6, vanilla 6 and total expenditure is 30. R 5, 9, 7 and total expenditure is 40. So let the number of banana, chocolate and vanilla cakes bought from each shop be X, Y, Z respectively. So the first question asks us to write the matrix equation AX equal to B using the above information. Okay. So from the question, we will state banana is X, chocolate is Y, and vanilla is Z. So we we need to uh, make this equation from the information given from this graph. So when we get this equation, so we need to transfer it into this formula ax equal to b. So we get 585466597, which is 3 by 3 matrix. XYZ is uh, XYZ and equal to 363040, which is a 1 by 1 matrix. This for A, this for X, and this for B. Okay, that's all. Alip, sorry, Fitri will continue with question B.
Okay. Question B. Obtain the adjoint matrix of A, hence find the inverse of matrix A. First, first we find a determinant A. By using the first row as a subject, we just use the formula for determinant A. Thus, we got the answer for determinant A equals to 14. Next, we find cofactor. When we all know that cofactor have its own sign, so we just put plus minus plus minus plus minus, and then we just use we just uh, find the find the minor for each of the elements. Okay, and then we just use we calculate the minor using the AD A times D minus BC. Thus, we get the answer for cofactor C equals to cofactor C. Arif, slide down. And yeah, that is the answer for cofactor negative 12, 2, 6, negative 11, 10, negative 5, 18, negative 10, and negative 2. As we all know, adjoint A equals to cofactor transpose. So by using the by using the cofactor transpose that we get the answer for adjoint A, and then okay, and then we use the since the question asks for the inverse matrix, so we find A inverse by using the equation determinant A times adjoint B adjoint A. So we sub the determinant A that we get earlier with 14, then we sub adjoint A with the one that we get when we get earlier. Okay, then we get the we just times and we get the answer as shown below. Okay, that's it for question B.
Alif,
Okay, for the last question, it asks us for to find the value of x, y, z using the inverse matrix of A that we obtain in B. First, we use the general equation AS equals to B, and then we add the inverse matrix of A at both sides. So when inverse matrix of A multiply with A, we will get the identity matrix. And identity matrix multiply with H, we get H. Then we get the new general equation that is H equal to inverse matrix of A multiply with B. Then we just substitute the value of inverse matrix of A that we get from B and the value of constant B that we find in question that we write in question 1A. And we just multiply like always that 6 per 7 multiply with 36, then 11 per 14 multiply with 30 plus minus 9 per 7 multiply with 40, then yes, let's continue the same way as in the other. Then we get the 3 to 1 matrix. So as the conclusion, we will get S equal to 3, Y equal to 2, and Z equal to 1. So that is the example of the real life question that we can relate to our real life. It it show us how to use the inverse matrix and matrices in our real life. So thank you for all the participants that here. So we can discuss about this question and our problem in real life. Thank you very much. Thank you, Arif. Thank you, Fitri. Okay, that's all. Thank you.
thank you.
Thank you.
Stop record.